Hello friends, this video on structure of atom part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 5. Then proton was discovered. So there is something called anode rays. As we have cathode rays, similarly we have anode rays. And this is nothing but a modified cathode ray tube. Here we have something called positive ions. This is nothing but if you see, you take any atom, and from that atom, let's suppose you take out one electron. You have atom, and from atom you take out one electron. What you get is positive charge, right? This guy is nothing but a positive ion. Please note, here we are dealing with positive ions. We are not dealing with electrons, or we are not dealing with photons also now. We are dealing only with positive ions. So this anode, the same cathode ray tube was modified and we get anode rays, and that is nothing but positive ions. It can be any positive ions, right? So they tried with so many ions. For example, you can try with sodium ions, you can try with hydrogen ions, you can try with helium ions. There are so many ions they can try, right? Please note, it is not the proton law. Proton is not yet discovered correctly. It's positive ions. You take any gas, you take out an electron from that, you get positive ions of that gas, and that's what they have used to study. Now what they found that these positively ions, they have some properties. For example, in the cathode rays tube, what we had was electron, and we saw that, as I told, you can take electron from anything. You take from gold, silver, anything, it doesn't matter, it has same property. But if you talk about positive ions, sodium ions, hydrogen ions, helium ions, they'll all have different properties, correct? So in this case, unlike cathode rays where we have electrons which is same, doesn't matter, you're taking the electron from gold or silver or copper. In this case, we're talking about the ions, sodium ions, copper ions, hydrogen ions, helium ions, and all are different. And that's why you see, in this case, the positive charge particles, they depend on the nature of gas. So nature of gas matters. Earlier, nature of gas doesn't matter for the electron, because for any element, the electron you take out is same. But here we're talking about the ions now. So the positive ions is different for different elements. So the nature of gas matters. Also, by this time we knew how to find charge to mass ratio, thanks to J. Thomson. They found that the charge to mass ratio also varies, depends on the gas. Charge to mass ratio also depends on the gas. Very easy, right? Here also, if you see sodium has one charge but the mass is more. Hydrogen also has one charge but mass is less. Helium has one charge but little more mass than hydrogen, less than sodium. So if you see, charge to mass ratio also will vary depending on the gas, right? Because we're talking about positive ions here. Please note, we are not talking about protons till now. We are talking about positive ions. So for positive ions, the charge to mass ratio and the properties will vary based on the gas. Now they found that all these charge, they were multiple of fundamental unit. Similar to Millikan experiment, if you see, he found that the charge was multiple of 1.6 × 10⁻⁹ coulomb. Similarly, here also they found that all the positive charge which they found using the experiments, they found that it was a multiple of a fundamental unit of electrical charge. And also they found that the behavior of these particles in magnetic field and electric field is just opposite as of electron. That means if electron was getting attracted toward positive, this guy is getting attracted towards negative. That means they have a positive charge. That means they can easily say that the particles we are talking about has a positive charge, right? Why? Because the electrons have negative charge, this guy has positive charge. And then they did the same experiment for the lightest ion, and they knew the lightest item is hydrogen. This thing they knew at that time, right? And then for hydrogen ion, whatever they got, H plus ion, they call that as proton. Because if you see, proton has only one, this hydrogen ion has only one proton. And that's what they found, proton. So you see, initially they started with the positive ions, and they found a lot of discrepancy because the charge to mass ratio was varying based on the gas, and they found the charge was multiple of fundamental unit, and that fundamental unit they found maybe the smallest, and they found the smallest charge, And to make it simple, they use now hydrogen ion. The moment they use hydrogen ion, what they called proton, because it has only one unit charge, and that's how they got proton. Correct. So unlike electron, which was easy because you take electron from any atom, it's all same. But for proton, it's different, right? If you're Na plus, H plus, He plus, all are different. So these ions were different. So if you see, for example, I have sodium. If you break, you'll get sodium ion plus electron, right? The best part with this guy is same. You take out from sodium, carbon, hydrogen. The worst part with this guy is different. Ion. You take out from carbon, the property is different. You take out from hydrogen, the property is different. That's why it took a little more time to discover proton than electron. So now we had proton, we had electron. We know the charge and mass of proton and electron.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.